rates of change. So we're starting differential calculus. And what differential calculus is a study of rates of change. Now we're used to seeing rates of change when it's a nice constant thing. Like, so this is an example of speed, which is distance over time. It's a nice constant thing. But in real life, we don't have things that are constants. Our graphs might curve. It doesn't draw something. There we go. And what we're really trying to find is the instantaneous speed of an object. How fast is it going at this one moment? Or at this one moment? Or at this one moment? That's the instantaneous rate of change. And that's what we're gonna learn when we learn differential calculus. Is how fast are we going at certain moments in this graph here. But to start that, we gotta learn about basic rates of change. So what a rate is just a comparison between two quantities of different units. So miles per gallon, miles. In here, if you know cricket, there's 99.94 runnings per inning. If you know Michael Jordan's basketball scoring rate, it was 31.1 points per game. Is the rate right? It's the change in two quantities of different units. It's just like, how much of this are we doing per this. So you average 31.1 points per one game. Right? It's slope. Now, constant rate of change is when it doesn't change. It's a constant here. So you can see in this case, my slope is going up 15 every single time. This is a constant rate of change. And in that case, it's easy to find the instantaneous rate of change. How fast it went one moment? Well, it's all the same. It's all 15. So remember, gradient does mean slope. That's what it is here. How we find the slope of these lines? It's like the normal slope equation. We do, so if I want you to find the rate of change just means slope, which in IB just means gradient, which for the most part just means do one of the formulas, the change in y over the change of x, or y2 minus y1 over x2 minus x1. Right? That's all it is. Rates of change is just slope. Now, again, right now we're doing constants, so it's a straight line, so it's easy. We do one of these formulas. Once it starts to curve, then it's a little different. So here we go with the curve graph. Right, so this graph's nice and curved. We can't find the instantaneous rate of change because it's curving. What we could do, at least not tools yet, we have to do more calculus to do it. What we could do for what we know is the average rate of change. We could say what the slope is on average from a certain point to a certain point. Over here, we could just say the slope. It's constant. It's not going to change. The slope here is the slope here is the exact same thing. The slope here is the exact same thing. The slope there. It's all the same. It's all 15. But over here, the slopes are going to be different. Right over here, wherever it's steeper, it's going to go faster. Wherever it's less steep, it's going to go slower. But we could find the average rate of change. And how do you find the average rate of change? Just find the slope. That's all it is. Now again, in this case, it matters what the endpoints are, because the endpoints from here to here, if you notice, you're just doing the slope of the line, right? Just doing the slope of that secant, of that chord there. That secant line. Right? So you're finding the average from this point to that point. If you change the points, then you find the average of two other points. That's how you find the average rate of change. Just find the slope. Right? So if a curved line, you have to find the average rate of change. If it's a straight line, you just find the rate of change because it's all the same. That's the difference between the straight and the curve for now. So let's do an example. For each, find the average rate of change from A to B. So we're going from A to B. So that point here to this point here. We want to find the average rate of change of that guy right there. So again, all we're going to do, average rate of change means slope, so we're just going to find the slope of this guy right here. So find a point. This point looks like it is 1 and 3. The point over here is 4 and negative 3. So average rate of change, this will be y2 minus y1 over x2 minus x1. Right, it's the change of y over the change of x. That's all it is. It doesn't matter which one's which. Let's just say this and this. So we get negative 3 minus 3 over 4 minus 1. So I get negative 6 over 3 or negative 2. So my average rate of change from A to B is negative 2. And that's the lesson.